This is a brief presentation trying to answer frequently asked questions about the multi-step lab on urbanization's impact on soil erosion. Also, the idea of this presentation can introduce the lab. What you see before you is the cover of the book written by a geomorphologist, David Montgomery, about soil erosion and how it relates to civilizations, as well as some other pictures about the impact of soil erosion on the landscape. There are 7 pieces to this presentation. Background material about Res Worman's model, understanding how urbanization impact on soil erosion, going over question 1 in the lab, then more background materials about the stock ponds study sites that you will be analyzing. Then walking you through the calculations that you will be doing. As an overview, with the cigar tank example, and then I will show you what you will do in question 2 through 5 for 4 different sites. And then the optional essay that you have chance to do to earn additional points. The PDF file that you have accessed provides all the details. That's really what you should focus on. You shouldn't do the lab from this presentation. So download the PDF file and it has all the materials that you need to do the lab. So now I'd like to focus on introducing you to Res Worman's model of how urbanization can impact soil erosion. Res Worman received PhD from Johns Hopkins University and he started working for the US Geological Survey. His PhD was in geography and he's famous geomorphologist. He did work in the Maryland area and he investigated how changes of land use can impact the amount of soil erosion. And so in this graph, the idea is that during the period of mostly forest conditions, there was an impact of human activities on soil erosion as forest was logged. Then with cropping, there was greater increase in the soil erosion. Then when the crops run away, there's more grazing. There was slight decrease because the wood and the woody tissue increased the forests a little bit. And then when urbanization hit with constructions, there's a sudden jump of soil erosion associated with the exposure of bare ground during home construction period. And then after the production of asphalt and cement, soil erosion drops back down again. The idea is pretty simple. It has to do what you learn in this class with relating to infiltration capacity, that if you take grass for example, when rain falls on the grass, vegetation like grass absorbs the moisture and you won't get soil eroding. But when you expose bare ground, that's when you begin to get rain splash, and rain splash to rilling and eventually quarreling. So the process of soil erosion with bare ground typically starts with rain splash. Rain hits the ground, it splashes up dirt particles, and when the rain continues, you begin to get a surface film of water. When that water film occurs, you can transport the dirt particles that were ejected from rain splash and you move it down to systems towards gullies, rills, and rivers. You've probably seen lots of scenes like this, where there's a construction activity, there's piles of soil that will erode, there's vehicle that contributes to soil erosion, and basically the rainfall is transporting the materials through the construction zone and up into river systems. This is probably also a view that you've seen before. You're looking at a dirt face where the house can be constructed on the flat ground below the dirt face. The dirt face has a lot of we call rills. The rills are where water begins to flow over the surface after you get rain splash, and the turbulent transport of water flow on surface cut these miniature gullies. The rills will grow into the gullies eventually. It's a common pattern that exemplifies how construction can increase rate of soil erosion. So the first question in the lab is pretty much a gimme. Why is this topic is important and why should you care? One example of why you should care is that there are check dams that collect flood waters. These dams are called flood control structures. And if there's too much soil erosion, the volume of sediment will fill in behind the flood control structures and it costs your money. It takes money to construct these, and if they fill in pretty much of sediments, then the urban center will have to pay for the either dig the sediments out or build a new flood control structure. Another example why this is important would be wildfires. Urban visitors to the wildland margins tend to set fires. They also drive motorcycles and ATVs. So if you are in urban area and you get a wildfire on the perimeter of urban area where there's motorcycles and ATVs traffic exposing bare ground, soil erosion will occur that will enhance the debris flow. And this is the view of debris flows moving into Glendale, California. And this case about wildfires, but you can also get ATVs and motorcycles accelerating erosion and producing similar although smaller scale effects. When you get sediment moving through urban systems, you can clog drains, and this leads to enhanced urban flooding. Also, urban soils contain lead and other contaminants that move through the city might be ejected in something like a dust storms or a dust cloud, and you breathe the pollutions that's associated with the soil erosion in the city. So now we get to the middle of the lab. I'd like to provide you a background of my research that set this lab for you. It's basically a study of cattle stock ponds, and it sounds pretty boring, but I think you will find that it's interesting. So these are views of about 20 stock ponds that are scattered on the Phoenix metropolitan area. Where you are looking at is the growth of the Phoenix area from 1912 to around 2010. In this view, the darker color blues are the core of the city. And as the city expanded, you get urbanization. The number things that you see there along with the catchments are the stock ponds that are your study sites. What happened was this, that Professor Ron Dorn, who is my PhD advisor, he went out and set baseline surveys in the collection area of water in the stock ponds, and he monitored the soil erosion that occurred. And I followed up all of these things and did additional work as a piece of my dissertation. And you're working with my data set in this lab. Each one of stock ponds has this sort of information. There is a catchment area or a watershed that you can see here on the left with little rills, and then they go into gullies and then into stream systems. All ephemeral channels that flow only when it rains. And what happens here is that the cattle grazing folks built berms to collect waters so the cattle could drink. And these are called stock ponds. What Professor Dorn did was to investigate how much sediment was accumulating in the stock ponds. So you are provided sort of information you see on the right for each of the stock ponds you will be studying. And you will be studying 4 of them that are randomly selected from pool of questions. You're given pictures or views what it looked like in different land use. In this case, a period of cattle grazing, wildfire, and house construction. And then in the complicated graph, you're given some pieces of information. How much mean annual precipitation occurred during the 20 years of study? Where did the most intense rainfall occurred that could do the most erosion? And then what were the land use changes? Cattle grazing period, wildfire period, and then during the house construction. But this graph has for you in the red, blue, and black are what erosion took place in the different land use period. In the cattle period, the blue and red give you a maximum and a minimum amount of soil erosion are calculated. And then there is the black one at the bottom, which is the natural erosion rates for this catchment area. Natural erosion rate was determined by studying cosmogenic nuclides like barium-10. So don't freak out. This is just background information. You will be given very specific information, how you do the lab, and I will walk you through it. So what happened is Professor Dorn made a grid in the stock ponds, drilled in rebar, and measured the amount of sediment that accumulated on the top of 9 rebar posts in the stock pond and monitor over time over a 20-year period. Okay, so now what will you do? Let me walk you through the basic idea of what you will be doing. You will be given the depth of accumulation of sediment that occurred during different land use time periods. So you're looking at an example of stock pond here on the left, aerial photo. It's cattle grazing period. And then a right aerial photo is where they built the road. The road was a source of a lot of dirt. The dirt washed off the road, went down to the stream system, and then you can see on the right where it accumulated in the stock pond. So you're given the depth of accumulation and the area of the stock pond, so that gives you the volume of accumulated sediment. Depth times area equals volume. So once you take the volume of the sediment in the stock pond is given to you, you can then find the area of stock pond using a Google Earth KMZ file. I will walk you through how to do that. And it is kind of spreading peanut butter on bread. The peanut butter has a certain volume in the jar, and then the bread has a certain area. So what you're going to be doing is taking the volume of sediment accumulated in the stock pond, and you're going to be spreading that over the watershed to find out how much average soil erosion occurred. Here's a screenshot of the PDF file of what you're given. You're given the land use history. You're also given my calculation for the natural background erosion rate. I used barium-10 to measure the accumulation of cosmogenic nuclide, and that allowed me to calculate how much soil erosion occurred over the last 10,000 years. So in the example of tank, you're given that the cigar tank watershed had a natural background erosion rate of very small amount. 4.5 millimeters of erosion occurred over a 1,000-year period. Okay? Millimeters are not very much. 4.5 millimeter is a big sand grain. It's a very slow rate of erosion. In this case, I measured it over the last 120,000 years. You're also given the depth of sediment that accumulated in the stock pond and the area of stock pond. So now I'd like to walk you through what you will calculate with the example of cigar tank. So this is an example. Question: which is the best answer for your analysis of the impact of humans on soil erosion in this watershed? It's a multiple choice question. You are given a correct answer and two incorrect answers. The correct answer is that you have to calculate the period of categorizing increased erosion from the natural erosion rate of 4.5 millimeter per thousand years to 46.5 millimeter per thousand years, or about the 10 times increase. Then the period of off-road vehicle use increased the erosion rate massively to 149 millimeter per thousand years, or an increase of 33 times. Thus, the bare ground exposure associated with driving off-road on the margins of Phoenix greatly increased soil erosion. And then you're given incorrect information. You have to discern which one of these is correct. First, notice there are big differences in the possible answers. That means the precision of what you're measuring is not terribly important. You just have to get into the ballpark. Second, you need to read carefully and slowly. And lastly, most of the points of this lab are doing these calculations. The essay is additional point opportunities. So you're given this sort of information as background for your tank. You're given the number of years of a particular land use. In this case, 14 years of cattle grazing and 5 for constructions. And you're given a view what happened over the 20 years period in terms of mean annual precipitation and intensity, how many days had really intense rainfall. As part of the Canvas materials, you will download a KMG Google Earth file. That's why you will be using Google Earth Pro. If you are trying to use the Google Earth browser on your laptop or on your phone, it won't work. You need to download the full version of Google Earth Pro. It's free. And then this KMZ file will work. So if you email me and say it's not working, the first question I'm going to ask you is, did you download the real Google Earth program? So stop the presentation, read instructions that are in the PDF file, and what you'll figure out is that it's pretty easy to get info and find out the area of the stock pond. I also strongly recommend that at this point you stop the presentation and you download the Excel file. The Excel file has this information from the cigar tank already in the Excel file format. What you can do is simply take the cigar tank example and put in information from the stock pond that you will be analyzing. So what I did in the Excel file is to take you through the Excel and following steps. And I just read about the bullet points. For the period from 1990 to 2004, 14 years, sampling in the 6,000 square meter stock pond showed that 0.288 meters of sediment accumulated. By multiplying the area of stock ponds times the depth of sediment accumulations, that gives you the volume of sediment. Then you divided that volume by the area of watershed that you get from the KMZ Google Earth file. The amount of thickness is incredibly small, so you will have to do multiplication to convert it. And eventually, when you do it step by step, you will get to the units of millimeters per thousand years. And then you compare the erosion rate and land use to the natural background rate. So maybe it's easiest for you to look at the table on the right, which is a copy and paste from the Excel file, and each step really requires that you get the area of the stock pond, you do some simple calculations, and you do some simple conversions. That's why I recommend you do Excel, cause that way you won't mess a number when you punched in the calculator. So then you will do this exact same calculations for a different land use period, and this is what it looks like in the Excel file when you've done it for the period of cattle grazing and then the period of different land use. House construction, road construction, wildfire, whatever. The bulk of the points of this lab is that when you do these same calculations for the 4 sites that are given to you by Canvas, you'll be randomly given some wildfire sites, some construction sites, maybe some off-road vehicle sites, and you'll do these sorts of calculations. These sorts of graphs, you won't use this information. You will be given specific information. This sort of graphical display just gives you an introduction to the study sites that you will be working on. You can see the wildfire change, you can see the house construction change, and you can get an idea for the land use that occurred in your study sites. There are 18 study sites altogether. The cigar tank is pulled out because I walk you through that example. So there is the pool of different sorts of areas that you will be able to get randomly. The essay question is an opportunity just for more points and for you to synthesize and bring to get this information. It asks you to think about how urban expansion of the sprawling Phoenix area impact to soil erosion in the Sonoran Desert. And you are given specific instructions on how to write the paragraphs and details matters. Grammar is not graded, but if you use texting sort of grammar, I won't be able to understand what you're saying. So try and write like a college student, write in full sentences, write in clear paragraphs, and give lots of details.